And I want to introduce the next panel, Jeff Stanley, not only the treasurer at IYBA, the ex-checker of our accounts, but president, owner of Gilman Yachts. Jeff's a lifetime yacht broker, started out in 1980, soon after graduating college. During his career, Jeff has sold well over 1,000 yachts from 25 to 165 feet. Also enjoys new build projects and has many to his claim credit from Neptunus to Johnson Yachts. So, Jeff Stanley.
Good afternoon, everybody, and thank you for staying for near the end of the program. And I want to introduce Andrew from Rolls-Royce and Jens from Volvo. Andrew, just for a minute, tell us about yourself, just a couple sentences, and introduce yourself.
Sure. So I've started under Detroit Diesel, and there's a long line all the way to Rolls-Royce. It's more or less a different purchasing from a different partner, but more or less stayed on the diesel engine side of the business. Since 2006, I've been strictly marine. So myself and my team's responsible for Series 2000, 4000. So it's about 1,000 kW up to about 6,000 kW engines that go into marine applications, both pleasure craft and commercial. And we're responsible for North America and Latin America.
Thank you. Jens?
Very good. Nice to meet everyone. Jens Bering, and I head up sales for North America, our technical department. So the applications, just like Andrew, some other functions as well. Been with Volvo Penta for 27 years and sort of worked my way up from application engineering and to where I'm at today. So it's been a fun run.
Thank you. So now I want to introduce you to the audience. Some of the audience are yacht brokers who sell just brokerage boats. Some of the audience sell new boats. Some are involved in new builds from planning through delivery. And many are involved in all facets of the business, but none of us are engineers, so go easy on us. And also we have a lot of people in the room here who ancillary to our business that are interested enough to stay and hear what we're talking about, so let's make it interesting. Okay, so over the past couple hundred years, the way we've moved our boats and yachts have gone from sail to steam to, most lately, fossil fuels. And there are those in the world who feel that the yachting industry is putting too much of a carbon footprint on the earth, and maybe we'll call it a carbon flipper print for our purposes. But actually, I read a statistic the other day that the carbon production for yachts and every ship in the world is only 3% of our greenhouse gases and carbon production. So really, we're kind of a small percentage. We're not the biggest problem. But be that as it may, we're going to talk today about some emerging technologies that will lessen the footprint on Mother Ocean. So these include cleaning the exhaust from the internal combustion engine via chemical or mechanical methods, actually sometimes both. There are alternative fuels for internal combustion engines, such as HVO. HVO is hydrotreated vegetable oil. And then there is hydrogen propulsion via fuel cells. There's diesel electric, there's solar power, and for smaller vessels, like we heard a few minutes ago, pure electric will work for a small day cruiser. But every day, it seems like there's a new yacht being launched that's using some of this technology. Yesterday's Boat International talked about the launch of Drizzle, which is a fed ship, which is a hybrid-powered boat. The day before, I saw something in a newspaper about a ferry being built for San Francisco Bay Area that is 100% hydrogen. And so these things are happening. I think it's going to be a little bit slower to get into our core business, but it is starting to happen. And personally, like many people in the room, I like to supplement my brokerage sales with new builds. I have a project going on in Turkey, I have a project going on in Taiwan. but they are going to different flag states. So in my meetings and negotiations with the client and the shipyard, it's important to discuss where the boat's going, how it's going to be flagged. And Jens, I'd like you to tell us, who's regulating the engine emissions?
Sure. Before I really go there, I think it's really important to perhaps depict a little bit about the emissions, because I think sometimes it's often talked about but seldom understood. And today we have greenhouse emissions, right? Global warming. We've heard a lot about that lately. And then we have what's called criteria pollutants. That is really what EPA has set out to do for quite a few years. Tier 1, Tier 2, Tier 3, Tier 4, we're all familiar with that. So greenhouse gases, that is really from CO2. That is global warming. That is one area. That is a byproduct strictly from fuel consumption. Period. Fuel consumption contributes to greenhouse gases. The only way we can combat that is with renewable fuel. So that is why there's so much talk going on about renewable fuel, because that is for global warming. Criteria pollutants, that is, and you'll hear both of us talk a little bit about it, that is really the after treatment systems and so on. So that is being, of course, regulated. We know that by our friends up in at EPA. We also have our West Coast friends, and CARB in California. They also regulate a lot. We know that. And that also is tied in together with IMO. And then there is a subdivision called MARPOL that is tethered under IMO. So that doesn't mean that China, they also have their own emission regulations. But in general speaking, broad terms, that is how the emissions are being regulated and why we're regulating those emissions. Particulate matters and NOx, that is really for health issues. Greenhouse gases is for global warming. And I think it was Frank that talked about it early on. A big portion of U.S. population, of course, lives close to the water. And that is where we also exist. And so on. So that is a high level why we have, or who regulates the emissions.
So do these bodies that are regulating a engine output of noxious gases production, do they vary from state to state? So flags, like an American flag versus a red ensign, do I have to guide a client to one set of rules where he's going to flag the boat versus another?
You do, but I'm going to turn that over to my buddy Andrew.
So in short, yes. Most of the stuff I think the people in the room are going to be most interested in is IMO requirements and EPA. And specifically to the discussion today, I think if we look to what's happened over the last 5 years and what's most important for everybody to understand, I think the most important on the yachting community would be the introduction of IMO Tier 3 certification. So what that means is for us engine manufacturers, this is the first time that we weren't able to meet the emission limits with just in-cylinder technology, meaning that the exhaust leaving the engine would be good enough to meet the emission limits for where it was being certified and used. So this introduced the need for after-treatment systems. You hear about EGR and SCR. I think for most of us in the room, especially on the marine side, SCR has been the solution used. And so with IMO 3, that first came into effect in January 1st, 2016. And with the lobbying of the yacht industry, we were able to push that out to January 1st of 2021. and look to further extend that out to the use of it in yachts. Unfortunately, that did not pass. So what has happened now is, as of January 1st, 2021, the requirement for IMO 3 is in effect and needed in vessels. So what has happened also is U.S. Coast Guard decided that they would not enforce that rule as long as it's in U.S. waters up until the end of last year. So what we've usually done to talk to our customers about, if you're building a vessel, so laying a keel between January 1st, 2021 to the end of 2023, is that you want to, you have to put together a justification that says there wasn't IMO 3 product available that would be the fit in your vessel. You want to document that, and we recommended to go one step further. I'm not a gambler, so I'd rather have all the details so I don't get a surprise later. Send that justification into the Coast Guard prior to building the vessel so that you already have that on record, and make sure that justification travels along with the boat once it's out there. Because once you got that approval, U.S. Coast Guard will grant that or grandfather that in after the date of December 23rd. So that's one thing to just keep in mind. So who in this room needs to be concerned about IMO 3? So it depends. And you'll hear a lot of it depends as we move forward with different technologies. And so for IMO 3, it's required for vessels that have a load line length above 24 meters and smaller than 500 tons. So load line length, what is that? There's a formula that the naval architects will go through and calculate based on the hull form. But just to simplify it, an easy way to look at it is when the vessel is sitting in the water, the length that we're talking about would be the length of the water at the length of the boat at the surface of the water. So this is just keep in mind, 24 meters is 82 feet. So you may see out there that there could be some vessels that were built after or starting now in 2024 that are 87 feet and they have an SCR system. And then you have somebody with the 90 feet and they don't. We have to keep in mind that it goes into that calculation. So it'll be based on that line at the level of surface of the water. So it's just something to keep in mind. If you see a discrepancy where it doesn't make sense, that something that's 87 needed it and something that was 90 didn't. So it's just things to keep in mind. So the first thing you need to do is decide, are you building a vessel over 24 meters? If you're staying under 24 meters, then life is more simple. You can stick with your IMO 2 and EPA Tier 3 recreational certification, which is probably on a lot of the vessels that are out there today. If you're above the 24 meters, then additional questions start. So the first question is, are you going to operate this boat in an ECA? So there's a lot of acronyms that come with this. So that's Environmental Control Area or Emission Control Area. So for us right now, that is the entire coastline of US and Canada, all the way around Hawaii, Puerto Rico, and the US Virgin Islands. So if you're planning on boating to any of those places and you're going to be above 24 meters, you're going to require IMO 3 with, in most cases, SCR. So that's the first question you have to ask. Next question is, are you U.S. or non-U.S. flagged? If you're U.S. flag, EPA has what they call delegated assembly. So it's an additional process that during the design and manufacturing of the vessel, there's certain documentation you need to provide, certain reviews you need to do, and it has to have that history of it during the build process and once you send the boat off to its customer. If you are not U.S. flagging it, then all that additional process is not required. And just to back up for a second, the intent of the delegated assembly is EPA wants to make sure that the engine and the appropriate after treatment system get properly mated together during the build of the vessel. Because if anybody that's been involved in any shipbuilding, typically the engine and the after treatment system ship separately, and it's the shipyard's responsibility to do the final install those components. If you're non-U.S. flagged, then you can get away without needing to do some of that. And you also get the flexibility of being able to turn the system off. So if you're operating the vessel in a non-ECA, then you don't have to have the SCR system functioning. Next question to ask is, do you want to sell this boat at some time? If so, then you need to think of, what do you want your market to be? Do you want to reduce your market to somebody that is not going to go to any of the ECAs and is never going to try to flag it U.S.? So these are things to keep in mind, that maybe you as the first owner are planning on doing a non-U.S. flag, but if you don't want to restrict yourself to another non-U.S. flag customer when you go to sell your boat, then you may want to already go through the process of the EPA portion of it so that it can be easily imported into the U.S.
You're right. You have a lot of acronyms.
I try to explain them all. So,
tell me, SCR, selective catalytic reduction.
Okay.
How's that work?
So anybody that's owned a car, at least up until the EV era, catalytic converter, very expensive to replace. I think everybody's probably been through that at least once or twice. So it's the same idea. On a diesel engine, what we're doing is we have to reduce our NOx, is the one emission that we need to use the catalyst or the SCR for. So what it does is the exhaust, raw exhaust coming out of the engine, gets mixed with DEF, so diesel emission fluid, and with that, it goes into the catalyst portion of the SCR, and then the product out the back end it'll be nitrogen and H2O. So that's how we're getting the reduction with SCR.
So again, that's going to be required for a boat over the 24-meter waterline length. I think a good example of that is Viking had a very successful 92-foot, 93 was motor yacht version, and they, Pat Healy lobbied hard with anybody who would listen, and nobody listened, and they now make a 90-foot Viking, so with a very high raked bow to get that extra length, but it falls under the load line length. So do you see that changing in the future? Do you see it going down to a 70-foot waterline length?
No, I don't. I guess your crystal ball is as good as mine. I haven't heard anything of them trying to reduce lower than that 24 meters.
Okay.
So,
all right, another acronym you said, DEF.
Yeah.
I'm building a boat with SCR, and we've got a 500-gallon DEF tank. So tell me, maybe Jens, tell me what DEF is and where am I going to get it?
Well, it's an additive that neutralizes, of course, the particulates coming out into the exhaust that's being captured in the muffler, because we need a burn of those bad emissions, right? Back to you can probably tell me better where you can get it, but because I have never myself been out boating and then having to source the DEF fuel. But I mean, it is of course it's something we're just gonna have to live with right now.
Yeah.
I mean, you can't get around it, and we might as well embrace it. And for me, it's important that we're here today. It's awareness, right? Because we all have to contribute to this Mother Earth and to the waters, right? That we really love and where we love to, do our boating at. So it's, but yeah, just a quick side note to that. I think most engine manufacturers, such as Volvo and then probably also MTU, when we developed Tier 3, coming from Tier 2, that was for us what we call combustion strategy. We didn't really have any hardware changes, but what we had to do to meet Tier 3 was actually pump in more diesel fuel. Counterproductive, but that's what we had to do. We created a warmer combustion process. That warmer combustion process is what burned off some of these particulate matters. That is essentially what we do now with the after treatment system. We just do it in a muffler and by adding this DEF fluid. Hopefully that makes sense. So it's just a different process that takes place outside the cylinder or outside the engine. And
so I did some research and AdBlue, DTF, you can buy it in the auto parts store in a 2.5 gallon,
yes.
God help my client with a 500-gallon tank.
But you don't want that.
But it's 32.5% urea and 67.5% purified water. How is it made? It's a combination of ammonia and natural gas that makes the AdBlue. So I suspect the big diesel trucks have to have it. Can't sell diesel cars here anymore, but they used to have to have it. And I imagine we'll see, I guess some point we're going to see a gas pump, like the no ethanol nozzle will be an AdBlue nozzle, possibly. But again, though, it's a bigger boat need, so there'll probably be a compartment in the fuel delivery truck full of AdBlue.
Yeah, I think, probably like you, right? You have day tanks,
Yeah.
If you buy our after treatment system, we have a we have a small tank. But typically, we also have a day tank, and that day tank is dimensioned after, I guess, you use it, right? So yeah, it all of a sudden becomes a lot of volume.
And it's just something else to add to. One of the questions we always get is, what if I run out? So as you said, trying to get a hold of it and that. So there's two potential issues if you run out of DEF once you're out on your boat. The one is that you could damage hardware, and I'll speak to that in a second. The other one is you could have an emission compliance issue. So the hardware one, what we've done at MTU, and I'm assuming most of the other engine manufacturers have done the same thing, is we have tank level monitoring inside that urea tank. So if you get to a low level, just like in your car, it'll warn you that it's time to either fill the gas, or if it's a diesel truck now, you even see in there, it'll tell you if it's time to replace your DEF. So you do that. If you can't because you're out in the middle of the ocean and you don't have access to any of it, then what we have done is we have engine protection in there, or SCR protection, that once you get to the low level, we will turn off dosing and we'll use the DEF that's still in the system to keep recirculating through. And what that's doing is protecting the dosers so that you don't have the hardware failure. But you will still have a emission compliance issue because you've been operating that entire time without the DEF, which was required for the NOx reduction. So that'll bring you into, again, going back to if it's U.S. or non-U.S. flagged. In the U.S., there's a self-reporting portion that you have to be aware of. So if you have this happen, once you get back and rectify the issue, you usually have 30 days afterwards, you need to send a report or an email to the EPA saying, these serial numbers were without DEF. We were not using our system for X amount of hours. The resolution was we had to refuel our DEF tank, and then you need to submit that in. On the non-EPA side, so if you're just under the IMO rules, it's a yearly report that everybody has to fill out. So you usually probably have to reach out to your engine manufacturer, or some will have it within like the automation system to print that report. And what it does is it'll go through and look at the performance of the after-treatment system for the year and show that there was no issues. If there was, then you have to put a little of an explanation of how you resolved it. So these are additional things that you now have to be mindful of when you're operating a vessel that has SCRs.
It's getting complicated. So, Jens, in my research for this little meeting, I came across something called the Paris Accord Agreement. What the heck is that?
Yes, very interesting, actually, and I can tell you that Volvo is part of the Paris Accord Agreement. It essentially, 2015, United Nations got together, and it really was to drive the greenhouse gas or global warming agenda. And so today, from that meeting, there are now, in public domain, you're going to look at it, 8,000 companies and counting that has signed up for the Paris Agreement. And that is then controlled, as I mentioned before, by MARPOL. MARPOL is then the governing body that drives that agenda with reducing greenhouse gases. Now, keep in mind that greenhouse gases we need. We rely on greenhouse gases. We just can't have too many of them. And that is the problem right now. We're pumping too many gases up into the atmosphere. When we get too many gases in the atmosphere, we create too much of a blanket around Mother Earth. Hence, greenhouse effect, right? We become too warm. Global warming, it is created by the blanket of gases shipped up into the atmosphere. So that is why we have to reduce them. It's actually a really interesting topic. So that is driven by what's called science-based targets, because this goes back to science. Our scientists are telling us that we got to reduce the global warming, right? So science-based targets is then what I think a company like Volvo, we are then driving after. We have made an agreement. And it's tough to get there. I'm going to just be honest. We have to do a lot, and that's what these companies they have to do that have signed up. So a big portion, of course, is technology, in pursuit of technology. and that's renewable fuel, and our emissions, so on top of that, it's also our industrial system. And I'm going to be honest, when we look at ourselves, right, because typically we have to start by looking at ourselves, we can do a lot. Volvo is a very environmentally friendly company, and I'm sure so is my good partner there. But boy, when we really start to look at it, I'm not proud of it, but we are very inefficient because we can ship containers around the world, right? From plant to plant, foundry in Sweden, and we ship engines to France. That's not very efficient, right? So that is us increasing our carbon footprint strictly by shipping. And that is part of also what companies want to reduce, for the greenhouse gases to get rid of, global warming. So it's a big topic. Part of the problem now, of course, lie in that we are in this transformational stage before we really hone in on what is the right technology enabled to get us to 2050. Because by 2050, we have made a pledge that we are going to be carbon neutral in the company I work for. And that's not easy. And as a boating community, it's also a very, very tough task because then boats tend to live for a very, very long time. If we take a truck, we say it's roughly a 10-year lifespan. That means that when we sell a truck in 2040, he's going to continue to emit for the next 10 years. So that means that there comes a point where we're going to have net zero trucks on the road enabled to meet, compensate for those trucks that we sold or have sold early on. So it's a delicate balance for the boating community. Those boats tend to live a long time. And so what we put in the water today, we're going to be stuck with for quite a while. And so
we've kind of talked about so far how we can fix the mess we made, where we're basically scrubbing the exhaust on the internal combustion engines that have been around for 100 years. New sources of technology like hydrogen as power source. Hydrogen by itself has got some problems storing it, not letting it get hot. Methanol can be reformed to hydrogen aboard the vessel, and this hydrogen goes into a fuel cell and makes electricity. Andrew, what is a fuel cell?
Okay, so you can look at a fuel cell very similar to a battery. So you have the main components, or you have an anode, a membrane that separates that to the cathode. So what happens is, as you mentioned, typical fuel for it would be hydrogen. So the hydrogen will enter the fuel cell, and the anode will persuade it to break the atom back into its proton and its electron. The proton will be the pass through that membrane and sit on the cathode. The electron will run through a wire to whatever we want to power. So typically, if we're using a fuel cell, it's probably going to an e-motor that's attached to a propeller. And then once the electricity passes through there, back to the anode where it matches up with this proton. And with the atmosphere, so oxygen from the atmosphere, you mix those together and you get water. So the byproduct, the emission of the fuel cell is just H2O. So but as you mentioned, that's where you'll hear, and I think Frank had mentioned it earlier, is that there's no one solution fits all. Once we deviate from an internal combustion diesel engine, there's going to be compromises in the ability to, like if we want to improve the environment, there's going to be compromises in other areas. So when you talk about the fuel, just to give you some ideas, if you wanted to have liquid hydrogen on that boat, you need to have it cooled to minus 253 degrees C. To do that, the tank the whole fuel system, so the tank and the fuel itself is about, I think it's 3 times the volume of diesel and 2 times the weight. So these are things you have to keep in mind. If you want to do compressed hydrogen, then it's going to be about 13 times the volume and about 7 times the weight. So these are things you have to keep in mind of, can you physically fit that on your vessel? And then you got to start looking at, if you're going to do some type of a hybrid system, are you only going to use the fuel cell for maybe loitering at the dock? Or loitering through the port net. And if that's the case, then you see, okay, how much hydrogen do you have to have on board? And as you mentioned too, methanol is another way that you could do it, is you bring methanol on board, and it's a reformer process that's required, and it extracts the hydrogen from the methanol, and then it uses that in the cell. Then you can go to a little bit more of a simplified fuel system. And you'd mentioned methanol in internal combustion engines. If you were doing some type of hybrid system where you're using a fuel cell and a propulsion engine on methanol, then there's some additional benefit there. You could have one methanol fuel tank that you could use to feed both that fuel cell and the engine.
So it's probably not a good system for my 39 Stamus, I'm guessing.
Going back to not one solution fits all. So, yeah.
So as you mentioned, these new technologies there's expensive. Takes a large vessel. There's a guy you may have heard of. He just had a boat recently delivered. Bill Gates. He's got a 390-foot fed ship, Project 821. He has cryogenic storage. Would you say negative 250 degrees centigrade?
Yep.
That's cold. And so it's going to take something in that size to make hydrogen viable. And even then, that doesn't run the boat. I understand it runs the hotel system on the boat for 10 days, or it can run the boat 10 knots between close ports. So it's an experiment. You still got a couple of giant MTUs in there, I assume. So doing the research on this was kind of fun. There's a project that has not been built. It's Marsh Architects advertising to find a client to build this 85-meter project, and it harvests its hydrogen to run the boat to fuel the fuel cell from seawater. It takes seawater, takes the hydrogen out of it, compresses it, stores it, converts it to electricity. But this is future. I got to believe. So Jans, besides hydrogen, which I know that Volvo is looking at, working, not releasing to public, what else is Volvo studying for marine applications?
So I can quickly comment on that. Because new technology development is so daggone expensive, we have a joint venture together with Daimler, which is Mercedes-Benz, on developing some of that, because it takes so much money to do. But to answer then your question is that I would say pretty much anything under the sun. And it's a little bit frustrating because right now we out here when it comes to new technology, because EPA has really not put a stake or IMO in the ground yet. So that really leads us to, we have to look at every single option that's out there and able to really narrow down the band to what is the most feasible aspect of going forward and able to reduce greenhouse gases and emissions and so on. So yeah, we have everything under the sun cooking, so to speak. Sort of when we started to develop, the after treatment, EGR or SCR, right? It was a little bit of what system is going to win in the end, which one is better for the application, also for the environment, for also for cost and so on, right, after the fact. So that's really where we're at right now. And as Andrew talked about, I'm sure that Bill Gates' 390-foot fed ship, that length had something to do with the fuel source, and able to fit it in the vessel, because it takes a tremendous amount of volume. So, yeah.
So we're in the stage of just throwing stuff against the wall, seeing what's sticking, basically, right?
Yeah.
And infrastructure, I mean, it's, it's I'm both Andrew and I will go out to customers, right? And they say electromobility. I want electromobility, and then you can ask, what does that mean? And it's a question mark, because electromobility is really a loaded question, and that's where we certainly have a disadvantage, I think, in the marine use compared to on highway. We know that a boat runs constantly uphill. It takes a tremendous amount of power to propel a vessel, in particular when you are semi-planing or planing, right? I mean, batteries really is not a good solution at that point in time, whereas on highway, it's easy, right? Once you get up and get rolling, it takes much, much less power. So, yeah, we're trying to find that silver bullet, which doesn't exist today, but we'll get there.
I've read that Yanmar is taking an internal combustion engine and powering it with hydrogen. That is not a fuel cell. They're something called ammonia cracking technology. We're using ammonia to get the hydrogen and actually run the internal combustion engine on it. So I think that might fall under throwing stuff against a wall. I don't know if that'll be around 10 years.
I mean, you're absolutely right. I think most of you guys are probably familiar with Maersk, big shipping line, and they are now pursuing a specific fuel type, enabled to reduce emissions. What you're talking about is another way of doing it. And maybe part of that problem, as I think sitting here today looking at that, is it becomes problematic at the fuel pump from a safety perspective. But we're smart people, and we'll overcome that as well at some point in time. So again, it comes down to infrastructure, distribution, and of course, there's some safety aspects too, and from our perspective, maybe that's one of them.
So Andrew, we're going to wrap this up to lead into our next speaker, HVO. Is it something that any recent MTU will accept and run on exclusively?
Yeah, so I think Frank had mentioned it too. This is an easy way for us to start to improve the emission footprint out there for marine. So for us, we have a lot of ferries operating in California. So anybody that's from that area knows that CARB has mandated the use of HVO in all of their commercial transit fleets. So between a bunch of test cells that we worked on, testing it there, also sending components out for additional durability testing, and we've burned well over 100,000 gallons through ferries in California. We've approved it for use with all of our engines, including those that are operating with SCRs. So the only negative that I heard from any customer on the use of HVO was on some of their older boats, so tier 1, tier 2, where I think everybody would know if you hit the throttles, you get maybe at least a little bit of puff of black smoke. Their complaint was the citizens around the port were no longer complaining about smoke. So the one big thing that you get with the HVO is a huge reduction in PM output.
But that's different than biofuel, right?
Yes, so big difference. So biofuel and HVO start with the same feedstocks. So they'll both use vegetable oil or animal fat, but it's in the processing of it. So the processing for HVO, I won't go into all the science of it. I'd probably get lost in some of it myself, is with HVO, it's a very pure fuel with the same chemical makeup as ultra-low sulfur fuel. So that's why they say it's a drop-in fuel. Biodiesel is not identical chemically, and they have some of their own impurities that you have to deal with. And typically, depending on the higher percentages, with the biodiesel, you're going to mix it with ultra-low sulfur. HVO, you can use 100% of it, don't need any additional supplements. With the bio, you're going to do like maybe a 20 or 30% mix, I think is the highest that we officially approve. And with that, you're going to have to look at shortening the service life on filters and other components within your fuel system. It also acts like a solvent. So if you were to start to use it, you're going to want to clean out your tanks very well before starting, because it'll clean all the stuff off of the tank.
Right, through the injector.
That's going through that. Well, hopefully most of it gets caught in the filter, but then what doesn't get caught could go to the injector. So there is some downfalls. Like we found so far HVO to be a win-win for the environment and for the engine. And they'll talk about minimum degradation in power, but none of our customers complained about any power loss.
All very interesting. I think we'll wrap it up, see if anybody has any questions. We have a question. Andrew?
The mic, yeah.
Yes, Jeff. How much depth do you need for 1,000 gallons of diesel?
I'm sorry, how much? Say again?
Yes.
How much of that depth would you burn for 1,000 gallons of diesel?
Well, the boat's not built yet. So let's say that the tanks are 14,000 gallons and the depth tank is 500. So I would like to believe that they've sized the depth tank to use the fuel on the boat.
So, and just to add to that, numbers that we typically see, I won't speak just to our engines, but what I'll see if I look on public websites on that, the range is usually between 3 to 10% of fuel consumption is urea consumption. So, and it all depends on how you're going to operate the boat, of how much you want to size your depth tank.
It's a long-range boat.
So it's a long-range boat. Like I said, you're not going to be able to find it maybe in different areas of the world, that you're going to want to take that with you. So you may want to keep a little bit more. And it also, for everybody to know, there's a shelf life on depth. So around 50 degrees Fahrenheit, I think you can get up to about 36 months on it. But as soon as you start to get into warmer, it degrades quickly. So when you get up to even 75 degrees Fahrenheit, you can be down, I think, like 18 months or something. So that's something to keep in mind too, that you want to size it appropriate for the way you're going to use the vessel, because if you have extra on hand, it may not benefit you if you're not going to burn it before it goes bad.
Any other questions?
Yep.
The reason why you're not using the ammonia concept to power diesel engines or any engine like Toyota's doing now with their engine that they produced.
The reason why we're not using ammonia?
Any research in that? I know Toyota's done some research into that type of fuel.
And we have too, but we're not there yet because of, again, it's a little bit of a, the distribution as such, right? We're trying to narrow down really which technology is going to win. We do, and it's already out on the market with dual fuel, and that's one of them, ammonia, as a dual fuel. And there are other dual fuels as well that we use, and so you can use the way dual fuel works is that you use that non-diesel fuel for low horsepower, and then when you really need to produce power, then you really go to 100% diesel, which is where we create, and then together with an after treatment system, right? But that's how we are now dosing the fashion. But that's a little bit depending on a little bit of the country, maybe the area, Amsterdam, for example, and these zero emission zones and so on. So it's we work with a couple of companies regarding dual fuel.
Yeah, and similar for what we've been looking at too. And just one of the other fields that we've looked at is more of where we're leaning more towards, like I think a lot in the industry is looking at methanol as the next fuel for internal combustion engines. It's the next closest to diesel as far as energy density. And so even, I think Frank had mentioned that doing a case study on, was it 5 or 7 or 8 different applications? I did one a few years ago for the company that we presented at Interferry on. We looked at one ferry that's used in California and said, okay, if we pulled the diesel engines out, we looked at doing fuel cells complete on batteries or methanol, and to see which technology would win. And again, it depends on the specific application, but we found that methanol was one that we were able to utilize in that specific profile without slowing down the routes or the amount of routes that could be done in a day for that ferry, where once we started looking at some of the other ones like the hydrogen and the batteries, you either sunk the ship, so you had to make a different hull, or you had to start pulling passengers off the boat to either make the runs. So it all comes down, I think, like Jens mentioned, we're looking at all the different technologies right now, seeing what makes the best sense, because we don't think we're going to hit that one solution fits all, but we want to find one that grabs as much of it as possible. But I think we'll be looking at a couple different solutions as we move forward.
Back, one more question. Wanted to know your thoughts on green hydrogen, since hydrogen today is typically made from natural gas anyway.
Green hydrogen, yes. There's, of course, there's yellow, there's black, there's gray hydrogen, but, green comes, of course, from renewable energy. So, yes, that's the only time it makes environmentally sense to do for us the way we see it today, to go with hydrogen. Unless you can do from renewable energy, offshore wind farming, for example, or something like that.
And the same goes for the methanol. When we talk methanol, I think most of the engine manufacturers is once we get to green methanol. Like I said, how you're doing that is, like even there's e-diesel, that is something you hear about, is you're using water to get the hydrogen, and how you're extracting the hydrogen from the water is with electricity, but you're getting electricity from a wind farm so that there's no emission footprint there. And then on the carbon side is carbon capture. So it's trying to pull it out of the environment, or there's also scrubbers you can put on factories and even large vessels if you want, that capture that carbon. Then you use that carbon in the hydrogen, again, through another environmental friendly method to process whatever e-fuel that you want to use. So that's, I think, the next stage.
Yep. Good.
I think we're good.
Thank you.
Andrew, thank you for coming.
Thanks.
Bye.